Welcome back to PrepForge. This is part 2 of our container series. In part 1, we packaged an app into a Docker container that runs anywhere, but Docker runs containers on a single machine. Today's question is, how do you run thousands of containers across a whole fleet of machines, keep them healthy, scale them with traffic, and update them with zero downtime? That's the job of Kubernetes, the industry standard container orchestrator, often written K8s. In this video, we'll cover the cluster, pods, deployments, services, self-healing, scaling, configuration, and ingress. By the end, you'll understand how Kubernetes keeps your app running, no matter what. Let's get started. Let's start with what Docker alone can't do. Docker is brilliant at packaging and running a container on one machine, but production isn't one machine. What happens when that machine dies? Your app goes down. What happens when traffic triples on Black Friday? One machine can't cope. And how do you deploy a new version to 50 servers without downtime? Manually? That's a nightmare. You need something that runs containers across many machines, restarts them when they crash, adds more when traffic spikes, and rolls out updates safely. Doing that by hand doesn't scale. Kubernetes automates all of it. You tell it the desired state, and it makes reality match continuously. Concept 1. The cluster. Kubernetes runs as a cluster, a set of machines working as one. There are two kinds of machines. The control plane is the brain. It holds the desired state and makes all the decisions. Its key pieces: the API server, the front door you talk to, the database that stores the whole cluster's state, the scheduler which decides which machine each container runs on, and the controller manager which drives everything toward the desired state. The other machines are worker nodes where your containers actually run. Each worker runs an agent called the kubelet, which talks to the control plane and manages the containers on that node. You declare what you want. The control plane figures out how. Concept 2. Pods. The smallest thing you deploy in Kubernetes is not a container, it's a pod. A pod is a wrapper around one or more containers that are tightly coupled, and it's the smallest deployable unit. Containers in the same pod share the same network address and can share storage, so they can talk over localhost. Usually, a pod holds just one container, your app. Occasionally, it holds a helper alongside it, called a sidecar for logging or proxying. The crucial thing to remember: pods are ephemeral. They can be killed and replaced at any time, and when a pod is recreated, it gets a brand new IP address. That single fact is why the next few concepts exist. Concept 3. Deployments and replica sets. You almost never create pods directly. Instead, you create a deployment. A deployment is a declaration of desired state. You say, I want 3 replicas of this image running at all times. The deployment creates a replica set whose one job is to keep exactly that number of identical pods alive. If you want to scale, you change the number from 3 to 10, and the replica set adds 7 more. If you deploy a new version, the deployment performs a rolling update, replacing pods a few at a time, so there's never any downtime, and it can roll back instantly if something's wrong. You describe the destination. Kubernetes handles the journey. Concept 4. Services. Remember that pods are ephemeral and get new IP addresses when recreated. So how does anything reliably reach them? Through a service. A service is a stable network address, a fixed name and IP that sits in front of a group of pods and load balances across them. Pods can come and go, scale up and down, crash and restart, and the service keeps routing traffic to whichever pods are currently healthy. So your front end talks to a service called backend, and never has to know or care which specific pods exist right now. A service is the stable front door to a moving set of pods. Concept 5. Self-healing, the idea at the very heart of Kubernetes. Here's the idea at the very heart of Kubernetes, the reconciliation loop. Kubernetes constantly compares two things: the desired state, what you declared, and the actual state, what's really running. Whenever they differ, it takes action to close the gap. Say you asked for 3 pods and 1 crashes. The actual state is now 2. The desired is 3. Kubernetes notices and immediately starts a new pod to get back to 3. Nobody paged. Nobody intervened. The same loop handles a whole node dying. It reschedules those pods onto healthy machines. This continuous, automatic drive toward the desired state is what people mean when they say Kubernetes is self-healing. Concept 6. Scaling. Scaling in Kubernetes comes in two flavors. Manual scaling is trivial. You change the replica account, and Kubernetes adds or removes pods. But the powerful one is autoscaling. The Horizontal Pod Autoscaler watches a metric, usually CPU or memory, and adjusts the number of pods automatically. Traffic spikes, CPU climbs past your target, and it scales from 3 pods to 10. Traffic drops, and it scales back down to save money. There's also a cluster autoscaler that adds whole machines when the existing ones are full. Together, your app grows and shrinks with demand with no human in the loop. Concept 7: Configuration and storage. Your containers need configuration and, sometimes, persistent storage, and you should never bake those into the image. Kubernetes gives you 3 tools. A config map holds non-secret configuration, like feature flags or URLs, injected into pods as environment variables or files. A secret does the same for sensitive values, like passwords and PI keys, kept separate and handled more carefully. And for data that must survive a pod restart, a persistent volume provides storage whose life cycle is independent of any pod. The same idea as Docker volumes, but cluster-wide. Config and secrets stay outside the image. Data stays outside the pod. Concept 8: Ingress. One last piece: how does traffic from the outside internet actually get in? A service is reachable inside the cluster, but exposing every service to the world is messy. Instead, you use an Ingress. An Ingress is a smart entry point, a layer 7 router that sits at the edge of the cluster. It takes all incoming HTTP traffic and routes it, by hostname or URL path, to the right internal service. So requests to shop.com/API go to the backend service, and everything else goes to the front-end service, all through one entry point with one place to manage TLS certificates. Ingress is the front gate of the whole cluster. Concept 9: When to use Kubernetes. So, when should you reach for Kubernetes? Use it when you're running many services at real scale across multiple machines and you need self-healing, auto-scaling, and zero downtime deploys. It's the industry standard for exactly that. When is it overkill? For a small app, a single service, or a simple side project, Kubernetes is a huge amount of complexity to operate. You'd be better served by something simpler. And that's the perfect setup for our final episode. If you want most of these benefits, orchestration, scaling, self-healing, but with a fraction of the complexity, there's a lighter alternative built right into Docker, called Docker Swarm. Said simply, Kubernetes keeps your desired number of healthy containers running across a cluster automatically. Explain the reconciliation loop, desired versus actual state, and you've shown you truly understand it. And that's Kubernetes, end-to-end. A cluster with a control plane brain and worker nodes, running your containers inside pods, managed by deployments that hold the desired state, reached through stable services, kept alive by the self-healing reconciliation loop, scaled automatically, configured with ConfigMaps and secrets, and exposed through Ingress. It's how you run containers at scale without babysitting them. In our final episode, we'll look at Docker Swarm, the simpler orchestrator, and exactly when to choose it over Kubernetes. If this helped, subscribe. Docker Swarm is next. Thanks for watching, and good luck in your interview.